today in person of Stephen Osonuga to the session. Hi, Stephen. Good to have you today. How are you doing today?
Thank you so much. It feels great to be here once again to learn, right? And it feels so wonderful to be here. Thank you so much for having me.
All right. So the floor is yours. You can take over the session.
All right. Thank you so much. Let me share my screen. So firstly, I would like to appreciate the Microsoft Nigeria Security User Group for the opportunity to also present once again. And so today, okay, so who am I? My name is Stephen Osonuga. I'm a lead blue team for SciSec Technology, and today we'll be looking at plan and implement virtual network security. All right, can you guys see my screen?
Yes, it's up.
Yes,
All
we can
right,
see.
thank you so much. Thank you so much. Thank you. Yeah, so today we're looking at planning and implementing virtual network security. So today we'll be looking at understanding the VNet, then the virtual network manager will understand NSG, ASG, and UDR, user-defined routes. We'll be looking at VNet peering, VNet, VPN gateway, virtual WAN, and monitoring, network monitoring. Also understand Azure encryption and express routes. Then also look at network security using Network Watcher. So first,
Ochijan,
what
please,
is
can
the
you,
Azure?
Stephen, hold on, sorry. Ochijan, please, can you turn off your camera, please? Hi, John. Please turn off your camera. You can go ahead, Stephen.
All right, thank you so much. Now, what is a virtual network? A virtual network is a private isolated network within Microsoft Azure that enables you to securely connect and manage resources like the VMs, applications, and other services. So its function is similar to a traditional network that is like our on-premise environment, but with the added flexibility and scalability of the cloud. Now, when we talk about virtual network, in our on-premise environment, normally we do networking to connect systems and servers. Now, in the cloud environment, we talk about the virtual network, that is the VNet, which connects our application, VMs, and also other services as well. Now, there are some key features about the Azure Virtual Network, which is that it allows for isolation and segmentation. Now, there's one thing that the virtual network brings is that if there was no virtual network, VNet in the cloud, and individuals create VMs, application, and also other services. Once a particular application or VM is compromised, then it will be possible for attackers to laterally attack other system that is not just primarily owned by the same person. Right? So the whole essence of a VNet first bring the idea of isolation to isolate a person's device so that even when that device is compromised, it doesn't reach other device in the same cloud environment. So, but then we know that Azure makes sure that they provide maximum security for their services, right? So, but that is just one of the key features of the Azure Virtual Network. Another feature is that it brings us some different connectivity options. Right? It allows for internal communication. It allows for hybrid connectivity. That is connectivity from on-premise to our cloud through the VPN gateway or the express route for hybrid solution. Now, we can control traffic flow, we can set up DNS, we can apply network security group and more within the VNet to ensure the protection and efficiency of our cloud infrastructure. Now, the third feature that I noted down that the VNet brings to us is the network security. Now, the virtual network allows us to use the network security groups, that is, we call it the NSG, to control inbound and outbound traffic to resources. It also allows us to employ the Azure firewall or third-party appliance for some advanced protection. Another key feature is it allows for custom DNS and routing, right? So just like we can see on the screen, it allows us to set up DNS, right? So Azure allows us to customize our DNS setting to suit our need and integrate with our existing naming structure. It allows us to use route tables to direct traffic as needed, both within the virtual network and to also external networks as well. Another key feature is peering and global reach. Now, we know that the virtual network, the VNet, helps us to bring isolation. But what if our company has like multiple VNets and if those VNets are isolated and we want them to still be able to communicate? How do we actually go about that? Now, there's a technology called the peering, the Azure peering, and also the global um, peering as well. So the VNet peering allows company to connect to or more virtual network to communicate with themselves as long as they're in the same Azure region. So they are able to pair with themselves and it allows communication within themselves. Then we also have the global reach that combines the Azure VNet and also our on-premise network for a seamless communication. Now, the last key feature that we have is it allows us to integrate um, the VNet with Azure services. So VNet can integrate with other Azure services like the virtual machines, the app services, and Kubernetes, making it a central component for building solution. Azure VNet is like building your custom highway system in the cloud with total control over the traffic flow, security, and connectivity. Now, let's understand what is a network. So I mentioned in the previous slide that the one of the key features was it allows us to secure our Azure
Hi,
virtual
Siri.
network
Your slide is not
by
moving. You're still on slide one. Can you hear me?
I'm
Okay,
still on
I
slide
can see
one.
it.
Okay,
I
let me
can
stop
see on
sharing
slide
my
two
screen.
now. I can see it
Is
now.
it on slide?
Yeah, it's
All
on
right,
slide two now.
beautiful, beautiful, beautiful. So now, if you can see my screen, this is a pictorial diagram of, on the left is the NSG, on the right is the ASG. Now, I'm sure we might have come across NSG and ASG while preparing for one or two of our exams in Azure. So we're just going to understand what these two actually does in our cloud environment. So both of them in Azure, they are used for managing and securing our network traffic. So but they are closely related, but they serve distinct purpose. Now, when it comes to NSG, that is the network security group. Network security group are used to control inbound and outbound traffic at the subnet or network interface level, right? It controls inbound and outbound traffic at the subnet or network interface level. So while creating an energy, you have to define some rules based on IP address, based on ports, and based on protocol as well. So it define which system can have access to which system through the network, then on which particular ports and on what protocol. So that is the rule for NSG, and it can be applied on subnet level and also on the individual virtual machine level. Then the ASG, which is the Application Security Group, allows you to group VMs, virtual machines, logically based on application or roles, which simplifies the creation of NSG rule. So basically, what this means is that it allows us to logically group virtual machines so that we can simplify our network security group rules so that if we have 4 VMs that want to access a database, instead of us to manually specify each of the VMs to those database, we can just group the 4 VMs in an application security group and then connect that ESG to the database. Now on our screen, we can see how the energy work by the left. So basically, um, for VM1 and VM2, they are on subnet, one on the virtual network. Now, um, VM1 has a NSG rule, one that allows internet access, both outbound and inbound, right? And also has a NSG2 rule that supports inbound rule as well. Then the VM2 also supports outbound and inbound connection to the internet on port 80, which is the HTTP protocol, as we can see. So the VM3 rather is on subnet 2 and also allows communication to the internet on port 80. So that means that the VM can actually browse the internet on this port 80 and also can receive communication on that particular port. And similarly, and so it is on NSG2 and it resides on the network interface card, the NIC, and then VM4 is on subnet 3 as well. Now on the right, we can see ASG. Now, our ASG, we can see that the VM1, VM2, and VM3, they are grouped in NSG1. That is this first energy, and this energy allows inbound access from the internet, right? And also outbound. But the sorry, hold on. So we can see that 1, 2, they are both on the application security group of web, and then this third VM is on application security group of logic. So because they're both on the web application security group, the rule apply for both of them. And then for this third one, it is not in the same application security group, and so it has a block access to the internet, right? So basically, ASG allows you to group to VMs, to virtual machines or more, and allows you to enforce network security group on them for a simplified creation of rules. Okay. Now, the key feature of the NSG is that it allows for traffic management. It is based on IP address, so you have to set the rule based on IP address, and the scope is for the subnet or the VM level. While the application security group, the key feature is that it is for logical VM grouping, and it is a group based, not an IP based. Now it's a group based kind of target, and then it is integrated with the network security group. So think of NSGs as the traffic cop that manage all the car, you know, when there's traffic. So the energy, manage the traffic, the moving and the coming of vehicle, while the ASG are the buses lane that organize group of passengers, which are the VMs, right? So just think of it like that. Can you see my slide 3?
Yes.
All right, beautiful. Now, what is user-defined route? UDR, user-defined route. So UDRs in Azure are custom routes that allows you to define specific traffic routing behavior within a virtual network. So by default, Azure provides system routes to direct traffic, but UDR lets override and add new routes to control how the traffic flows between the subnet, network interface, or even to the on-prem network via the VPN or the express routes. For example, UDR can be used to direct traffic to a network virtual appliance for inspection or to route traffic between subnets. So basically, even though the Azure comes with some custom rule, right? So the UDR allows you to override those routes. And for example, if you want to pass your VM traffic to the network virtual appliance for inspection, the UDR comes in play and allows you to override the route and make sure that the traffic goes between the network virtual appliance for checking for it in the other end. So EDRs are typically applied at the subnet level and can be used to control and secure traffic flow in complex network architecture. So some key features of the UDR is that one is provide custom route creation. That means that you can define routes for specific traffic flow, such as sending traffic through a firewall or a network appliance. And this is particularly useful for scenarios requiring advanced traffic inspection or logging. Secondly, is that um, it allows route table association. UDRs are stored in route tables, which are then associated with subnet in your virtual network. So each subnet have its own route table. Thirdly, is that it has different next up types. So EDR specify the next up for traffic, which allows the override. Right. So one of the next up is that you can send the traffic to a virtual appliance, like I've said before. You can send it through the virtual network gateway to route the traffic to a VPN gateway, and you can also direct it to the net to the internet as well, right? And also you can also drop traffic if you want. Number four key feature is that it gives priority over system routes. So basically, UDR take precedence over the Azure default system routes, allowing you to override default routing behavior. Number five is that it is flexible and it gives you control. UDRs are especially useful in complex architecture like the hub and spoke topology, where traffic flow between spokes need to be managed precisely. So those are the five key features. Number one is that it allows for custom role creation. Number two is that it comes with a route table association. Number three is that it has different next up types. Number four is that it gives priority over system route. Number five is that it gives flexibility and control. Okay, if you're with me, say yes. If you're with me,
Yes.
say yes. I want to know.
Yes.
All right, beautiful.
Yes.
Beautiful, beautiful, beautiful. So that is the user defined route. Basically, just think of it as an override for a greater cost. So for a better inspection of the network traffic that we have. And like I said, it is mostly useful in a complex architecture like the urban spoke technology. Okay. Now, we'll be seeing white background since let's just change the theme a little bit so that our eyes can balance a little bit. Now let's understand the VNet peering and VPN gateway. All right, so they both sound like they do the same thing, but do they actually do the same thing? So we're going to find out. Now, virtual network peering allows seamless connectivity between two virtual networks in the same or different region. Now that depends on the configuration that you set. So for planning, ensure the VNets do not overlap in the IP address range and consider the traffic flow requirements such as regional connectivity or cross-region communication. Now, when you want to peer to virtual network, so we know that a virtual network is like an isolated internal network. For example, a virtual network can be 10.0.0.0/16. That's a virtual network, right? And that virtual network can be 10.0.2.0/27. So we want to make sure that okay, just pardon me. Let me just put like a notepad on the screen. So let's say we have 10.0.0 or 10.0.3.0/24 on VNet 1. Okay, and then we have 10.0.0.3 as well. Sorry, /24 on VNet 3. So when it comes to VNet pairing, we want to make sure that we don't have um, this overlapping IP range, because if VNet 1 has this range and VNet 3 has this range, by connecting, because we know that there'll be a device under this VNet 1 that is probably 10.0.3.3, right? And then if another on this one has the same IP address, it it conflicts the network, and so this won't be allowed in the Azure VNet pairing, because they both have the same CIDR range, class interdomain routing, I believe, if I'm not wrong. So basically, we want to make sure that the both VNets do not have same IP range, to avoid overlapping. And so that is just what VNet pairing does. Then the purpose of VNet pairing is that it directly connects two virtual networks to enable seamless communication, as if they were part of the same network. And some key feature is that it has extremely low latency and high bandwidth, as traffic stays within the Azure backbone. Now, one of the requirements is that as long as they are both in same region, or even different region, but same region allows, a very fast bandwidth, or very high bandwidth with a low latency, because they're in same region, right? So, but VNet pairing also supports cross-region, which is the global VNet pairing, and it still allows you to connect to to pair with another VNet in a different region, which is the VNet global pairing. Then what is the VNet gateway, the virtual network gateway? A VPN gateway connects an Azure VNet to on-premises network. I'm sure we all know what on-premises is by now, right? So that is our physical environment, our physical server. That's what on-premise means. Don't make it look like a big grammar. So it allows us to connect our Azure VNet, that's our cloud VNet, to our on-premise network via a secure IP security / IKE VPN tunnel. So we need to plan for appropriate bandwidth, gateway SKU, and VPN type. So either we want to use a site-to-site connection from our on-prem to the cloud, or want to use a point-to-point or a VNet to VNet. So ensure that your on-premise VPN device supports Azure VPN configuration for this case scenario. Now, a VPN gateway, its primary purpose is just that it uses a virtual network gateway to connect VNet and on-prem network for other external resources using the VPN or the express routes. And some key features include that it enables hybrid connectivity by linking Azure VNet with on-prem network. That's hybrid connectivity. It supports point-to-site, site-to-site VPN or express route connection, and it can connect multiple VNets via a single gateway in a urban spoke topology. Okay, so that is the major difference. So VNet gateway basically uses it connects the VNet with the on-prem through the through secure IPsec VPN tunnel, while the VNet pairing is a cloud-based connection that connects two virtual networks together. Moving on. Now, what is the Azure One, and also what is the Azure Virtual Hub? The Azure One, or the Azure Wide Area Network, is a centralized hub for managing global network connectivity. It simplifies the process of connecting multiple branch offices, remote location, and data center to Azure, providing optimized, secure, and scalable network connection. Virtual WAN allows for easy integration with VPN, express route, and site-to-site connectivity. The purpose of the Azure WAN is that it is a networking service designed to connect on-premises, branch offices, and Azure VNet across large geographical area. And some of its features include that it acts as a global networking backbone. Then it provides connectivity through a site-to-site VPN or a point-to-site VPN, and even through the express route circuit. And then it also provides a centralized, and it simplifies the management of large-scale network deployment. Now, what is now the Azure Virtual Hub? The Azure Virtual Hub is a component of the virtual one that acts as a central point for connecting VNet, VPN site, and other networks. It enables routing, security, and traffic management across the Azure network, and it provides centralized services like network security, monitoring, and scaling for resource in a specific region. Now, the primary purpose is just that the Azure Virtual Hub is a part of the Azure one, and it just acts as a central connection point within the Azure for multiple VNets or connection. Okay, and some feature includes that it is a logical hub that enables routing between VNet branches and external sites connected to Azure. Then it supports secure connection via a built-in service. Now, Azure encryption. Azure encryption is broad because it covers different aspects of the encryption, which could be the client-side encryption or it could be the server-side encryption. So basically, Azure supports various encryption models, which includes server-side encryption that uses service-managed keys. Then it also uses customer-managed keys in Key Vault or customer-managed keys on customer-controlled hardware. Now, the purpose of the Azure offers robust encryption method um, to secure data both at the client side and also at the server side, ensuring protection during storage and in transit. Now, we have the client side encryption and then we have the server side encryption. The client-side encryption is this encryption is performed by the client before data is sent to Azure for storage, ensuring that Azure never sees the unencrypted version of the data. That's what it basically does. So the user is the one that actually encrypt this using a customer managed key before it gets to Azure for storage. So and data that is already encrypted the data encrypted by an application that is running in a customer data center or by a service application. Now, some key feature about the client-side encryption is that encryption keys are managed entirely by the client, giving them full control. So it is often implemented using custom application or tools like the Azure SDKs. So some scenarios about this client-side encryption could be it is ideal for scenarios where regulatory compliance or security policy require client control encryption. Another use case is that you ensure data privacy for sensitive information as well. Now, the responsibilities on the client because the client must handle encryption, decryption, and also key management as well. Now, for the server-side encryption, this encryption is performed by Azure after the data is received, so securing data at rest within Azure Storage Services. And the three server-side encryption model offer different key management characteristics, which you can choose according to your requirements. So we have the three types of the server-side encryption. We have the service managed keys, we have the customer managed keys, then we have the customer provided key CPK as well. So the Azure managed key, this is where Azure handles encryption and key management transparently. So no user intervention is needed, and it actually simplifies the whole process of encryption because Azure is the one that is managing this encryption using the AMK, which is the Azure managed keys. Secondly is the customer managed key. This allows customers to provide and manage their own encryption, even on the server, without encryption key using the Azure Key Vault, right? And it offers more control over encryption practices. So the customer uses the Azure Key Vault to create his own managed key, and then provides that for encryption on the server side. Then thirdly, we have the customer provided key (CPK), and the customer supplies encryption key for Azure to use during data encryption operation, and also ensure that key never leaves the customer control. So the customer managed key is that that uses the Azure Key Vault, while the customer provided key is that the customer is in control of the encryption key. And yeah, so that is that. And then we also have the Azure encryption in transit. So while it is not specifically part of the client side or server side encryption, Azure also secures data in transit using protocols like the TLS. TLS stands for Transport Layer Security, ensuring safe communication between client and Azure services. And so Azure has a storage service encryption, which is the SSE. That's for the Azure encryption. And then we also have the encryption of data at rest with Azure SQL database. We have the encryption of data in transit, which uses the TLS. We also have the in-transit encryption in VM. So these are the different encryption that Azure provides in the cloud. We have the Azure VPN encryption, which is the IPsec IKE encryption that comes with the VPN gateway. Right. Then it also has the in-transit encryption in data lake. Then it has the key management with key vault. So it provides these different Azure encryption services. Now, moving on from encryption, we have the Azure Express routes. Azure Express. Well, I've been talking about the Express routes when it comes to VNet pairing or the VNet or the what do we call it again? The UDR or the virtual hubs. Now we get to understand what the Azure Express route is and what does it primarily do, right? Because we're curious about its primary purpose, why Azure created this, and why does it stand out. So the Azure Express route is a networking service that provides a private, then a dedicated connection between your on-premise infrastructure and Microsoft Azure, bypassing the public internet. Do you get that? So it provides a private, dedicated connection between your on-premise infrastructure and Microsoft Azure, bypassing the public internet. This ensures high performance, reliability, and security for your hybrid cloud environment. Now, here's a breakdown. One of the features of the Express route or the Azure Express route is that it provides a private connectivity. So, unlike VPN connection that uses the public internet, Express route offers a private connection which reduces the latency and also increase reliability. The Express route also provide high performance. So it is designed for bandwidth intensive application, and Express route supports speed ranging from the 50 megabytes per second to 100 gigabytes per second. And it is ideal for scenarios that requires consistent and high speed data transfer. The Express route also comes with an enhanced security, which eliminates exposure to internet-based attack. It ensures that data flows securely between your environment and Azure securely. Then the Express route also has a global reach, which connects your infrastructure to Azure data center worldwide using global providers, and it enables seamless integration across different geographical locations. It provides multiple connectivity model, which include the point-to-point and the any-to-any, as well as the express route direct. So the point-to-point means that it connects your on-prem network to Azure directly. The any-to-any means that it connects multiple branch locations to Azure through your wide area network, your WAN. And then the express route direct provide the high performance connection directly to Azure data center. It also supports Azure services. So it connects core Azure services such as the storage, virtual machine, and other platform as a service offering. And then it supports Microsoft 365 and Dynamic 365 workload as well. So some benefit of the Azure Express Routes is that it provides a predictable performance. It also gives high availability for your connection. It comes at a reduced cost, and also it supports hybrid integration for our connection as well. And some of the limitation is that express routes requires collaboration with a network service provider, and the initial setup cost can be higher than other connectivity option, making it better suited for enterprise use cases as well. So we understand what the express route does now. It provides us like a secure um, communication from our on-prem to Microsoft using a secure link. And so that means our on-prem will have access to our Microsoft resource using the express routes. And yeah, so that is basically the overview of the Azure Express routes. Moving on, we also have the Azure Firewall or firewall settings for Azure resources, which also is part of the network security for Azure. The firewall setting comes with different settings. One is the Azure native control. Second is the third-party offering. Third is that it terminates outside the firewall, which is the perimeter network, and fourth is the network extension. So the Azure native is the Azure firewall and web application firewall in the application gateway that provides basic security. They are simple to set up and to configure, offering built-in protection for platform as a service resources. We have the third-party offering, which include the next generation firewall and other third-party solutions. These can offer advanced security features but require more complex configuration compared to Azure native. Pardon me, this is Azure native control. Then the perimeter network, which terminates outside the firewall. Traffic is filtered at the network edge outside firewall before it reaches the internal resource, providing external facing protection. And then we have the network extension, which terminates inside the network. So traffic is filtered inside the network, allowing more control over internal traffic, and is the recommended approach for path security. Then lastly is the network watcher. The network watcher. Now, the Azure Network Watcher provides a suite of monitoring, diagnostics, and troubleshooting tools for the networking in Azure. So once we've configured our NSG, our ASG, our VPNs, and all that, and we are having issues with our connection one way or the other, the network watcher comes and give us a diagnostics, monitoring, and troubleshooting capabilities to let's say diagnose our network. Now, it comes with some key capability feature, which includes the topology. The topology allows us to visualize our network resource and connection, offering an overview of Azure environment network architecture. Then secondly is that it comes with the connection monitor, and this monitor and tracks the connectivity between Azure resources or between on-prem and Azure, checking for latency, packet loss, and availability. Then it also comes with packet capture, which captures network traffic for deeper analysis, helping in identifying issues like drop traffic or unwanted traffic. These are part of the troubleshooting tools. Then number four, it comes with network performance monitor. This allows you to monitor network performance and provide insights into issues related to network latency, packet loss, and availability across the entire network in your subscription. Number five, next up. This helps determine the next stop for a given destination IP, providing insight on how traffic is routed within the virtual network. So basically, this just shows you the next IP address um, that comes after you try to route your network. Then number 6 is that it comes with IP flow verify, and this validates whether traffic is allowed or denied to or from a particular IP address, ports, and protocol, helping to troubleshoot security group rule. Now, this IP flow verify is very useful when it comes to configuring network security groups, and you want to verify if you configure the settings well. So the IP flow verify checks for flow between virtual machines in your cloud environment and through a specific port or based on IP address actually. The number 7 is that we have the security group view, and it displays the effective security rules applied to a network interface, helping identifying potential access control issues. Number 8 is that it comes with traffic analytics. It helps you to analyze network traffic flow in and out of your VNet, helping you to understand traffic patterns, to identify bottlenecks, and to enhance security. So those are the basic understanding that we need to know when it comes to network security. And so just to test our knowledge, right? I have 2 questions on the screen. So a company wants to configure network security as a natural extension of an application structure, and they want to group virtual machine and define network security policy based on those group. Which Azure feature should you use? If you know the answer, just type it in the comment section. Are they going to use the NSG? Are they going to use the virtual network service endpoint? Are they going to use the application security groups? Feel free to drop your answers in the comment. So a company wants to configure network security as a natural extension of an application structure. They want to group virtual machines and define network security policy based on those groups. Which Azure feature should they use? I'm waiting for your response. Someone said network security group. Okay. Okay, people are saying energy. A company, I'll read the question again. A company wants to configure network security as a natural extension of an application structure, and they want to group virtual machines and define network security policy based on those groups. All right. So which Azure feature should they use? So they want to group virtual machine. So if your answer is energy, type energy. If it's ASG, type ASG. If it's virtual network service endpoint, type it. We have 14 people in the call. Okay. So NSG is network security group, and its primary purpose is to filter inbound and outbound connection to and from a virtual machine. But now this company wants to group virtual machines, and primarily energy is not used for grouping, it's just used to monitor inflow and outflow. I told you it's like a cop that stands at the traffic and see if people are allowed to actually move or come, or they have to stop, at the traffic. So I would say energy is not the answer. Another person says ASGs. If I am right, are you sure? Are you sure? I mean, you have to be sure at this point. You have to be sure. Is it ASG, or is it the virtual network service endpoint? So, to save our time, the ASG purpose is to group different virtual machines so that a single energy can be applied on those group of virtual machines, or a single network security policy can be applied on those groups to allow inbound and outbound. So the answer is the application security group. Then second question, You guys tried. You guys tried. Second question is that a company needs to connect to virtual network in Azure so that traffic can be routed between them. Which virtual network connection type should they use? Should they use a virtual network peering? Should they use a global peering? Or should they use a VPN gateway? I'm waiting for your answer. Uh, Samuel, Stephen, Ephraim, Theodora, Opoyemi, type your answer. Which virtual network connection type should the company use for this type of connection based on what you've learned today? VPN. VPN is not one of, okay, VPN gateway. Probably mean VPN gateway. Ephraim said VPN. Theodora said virtual network peering. And Opayemi said VNP. That has to be virtual network peering too as well. And we're waiting for Busayo. Virtual network peering, virtual network peering. All right, all right. Chisom, David, VPN, virtual network peering. Okay, Ephraim corrected himself. He says VNP, virtual network peering. Then Chisom David said VPN. Is it VPN Chisom or is it VNP? Which one? Because it's like Ephraim made that same mistake. Is it VPN gateway or VNP? Well, the you guys are actually correct. It is the virtual network peering. Right, so the company needs to connect to virtual network in Azure so that traffic can be routed between them. Wait, it says in Azure actually. Okay, yeah, so it is virtual network pairing because virtual network pairing connects to Azure virtual network so that they appear as one for connectivity purpose. So traffic between the virtual machine is paired. Sorry, traffic between virtual machine in the paired virtual network is routed through the Microsoft backbone infrastructure through private IP addresses only, so no public internet is involved. And this provides a low latency, high bandwidth connection and is useful in scenarios such as cross-region data replication and database failover. So yeah, you guys will have access to the slide after the practical. So yes, so that is the two questions. I'd have loved to present more, but they all can't contain one slide. Right. So moving on. So in summary, we've been able to understand the virtual network. We've been able to understand NSG, which is the network security group. We understood the application security group. We understood the UDR. What does UDR stand for? Let me know in the comments. We also understood the difference between the VPN gateway and the VNet peering as well. And then we talked about um, Azure Virtual One and Virtual Hub. Then finally, we talked about the Azure encryption and the express route. Okay, so that is it for the theoretical. Now, let us go to the lab section. All right, correct. UDR stands for user defined route. Thank you, David. Let me share my screen for the practical. Okay, yeah, my screen is still sharing. Okay. Beautiful, beautiful, beautiful. All right, so what do we have? Now, this is our environment and our focus for today. Let me increase. All right. So our focus for today is the virtual networks. So in previous trainings, we've looked at entry ID, authentication, authorization, app access. So all that are in the entry ID. Now, our focus today is the virtual networks and what it offers to us. Okay, and how we can manage virtual networks. Okay, so now when by default when we create a virtual machine, okay, I'll increase the size once more. When we create a virtual machine, by default it okay, let me just go through the whole process. So when we come to virtual machine and then we create an Azure virtual machine, I just want to demonstrate something for you guys. Sorry, please, is it visible enough right now? I believe I've
Yes,
increased it
it
to the
is. It's
maximum.
visible.
Yes, it's okay.
All right, thank you so much. Thank you. So if I try to create a virtual machine, we're going to choose our resource group, then give it a name. I'm out of test name, but let me just use test 1, 2, 3. Then we choose our region, availability zone, no redundancy, standard, security, and now image type. Let's say we want to create a Windows server data center with a 1 GPU, 3.5 gig. We're going to give a name and put in a password. So after all these details, we can come to networking, and then we'll see the option of either to create a new virtual network or to use an existing virtual network. So that is just my major emphasis here. So it is good for you to actually create a new virtual network on ground so that you can link the virtual machines that need to be linked to that particular virtual network. So if you have a web application set of VMs and you have an application set of VMs, so you know that you need to create 2 virtual network, one for the web application and the second for the application virtual network. So it's important for us to create a VNet on ground so that we can have to group those machines based on those virtual networks. So I'm going to come and create a virtual network. I'm going to create a virtual network. Now, so just like every other Azure subscription, you need to also select your subscription is a pay-as-you-go service, and then choose your resource group. I'm going to choose my resource group. Then what is the name of my virtual network? This has to be my web VNet on this US. Now, always take note of the region that you deploy your VNet to. Right. So I'm going to leave this as the US. Now I'm going to click on next. We have the security group, which and from here we can see that if we enable the VNet encryption, it encrypts our traffic traveling within the VNet. Virtual machine must have accelerated networking enabled. Traffic to public IP address is not encrypted. Then we also have the option of the Azure Bastion that allows us to use our browser to actually connect to our VM. So this comes with an additional cost, so it's important you don't use that. We have the Azure Firewall if we want to integrate a firewall to the virtual network, so we can enable this option. But we're just going to go with the default settings today. Right, we have the Azure DDoS network protection. Also, this also comes with an additional cost, as we can see here. So then we'll go to the IP address. This is another important part of the section because you need to know how you define your IP range. Okay, so by default, Azure just gives us the 10.0.0.0/16, and this /16 has total number of 65,536 addresses. So, but for me now, let's say because this is my web virtual network, I want this to be on 10.20.0.0/16 network, so that I can identify that this particular network range is for VM, right? So it's for web rather. So I can click to add a subnet if I want. So this subnet allows me to drill down the whole network to a particular smaller network. So the purpose of a subnet is to divide your bigger network into small subnetwork. Right, so that's a subnetwork. I'm sure you guys understand. So you're going to put the purpose, right, of the subnet. So if we are going to integrate all these other ones, so we're going to, for example, for the Azure firewall, the name has to be Azure firewall subnet. But no, let's just leave this for another time. We're going to go with the default settings for today. Then we'll come to tag. We're not putting any tag today, and then we'll just create a virtual network. So it runs validation to check that the settings are not mismatched, and then we can now go ahead and create our virtual network. So it might take a minute or two. You just have to be patient. All right. Deployment in progress. We just have to wait a little while. Then our web VNet will be deployed successfully. Okay, brilliant. Brilliant stuff. So that is basically deploying a virtual network, a VNet. Now, okay, so if you click on the virtual network, we're going to see all the pre-built settings that comes with it. So this is the overview page that shows us the details about the virtual network. The web VM comes with a 10.20.0/16 address space. Then if we come down to access control, here we can manage the, what do we call it again? The rules and administrator for this particular virtual network. So we can give a particular user a contributor access and other rules. If we come to settings, we can see the different protection and settings for a virtual network. You can see address space, connected device, subnet, bastion, DDoS firewall, and so on. We can also see our pairing that we just did in the question, right? And then so we have private endpoints as endpoints, which are coming then to this in um, our later training. Then we have the monitoring that allows us to monitor the VNet. Then we have the automation as well. Then the help section. If you're finding difficulties, the help section is there for you. Okay, so first I'm going to demonstrate the network security group, which is the NSG. So in practical terms, how does NSG work and how does the ASG work? So now uh, NSG works, like I said, on either the subnet level or the network interface level. So now I'll go back. On the network interface level, it applies to virtual machines. I have to go back and come to virtual machines. So like I said, it allows or block out inbound and outbound communication. So I have this virtual machine, though it is stopped, but I can still modify the settings of this VM. Now, if I should come to the networking tab, and come to network settings. Here I can view the network settings of this particular virtual machine, and now this is on the network interface level now, right? So we can see that it comes with a network with a NSG. So I'm going to click on this NSG, and it's going to take me to the VM energy settings. Okay, so this is the overview page, and you guys can see I've done some configuration on the inbound and outbound security rule. So let me just explain one or two things around this NSG. So this is a Linux operating system, so very important that the SSH port, the SSH port has to be open so that me coming from outside, I can access the system through the SSH, through the IP address, right? So, but then there are also other custom rules now. So, if I want to actually allow, people from outside to SSH into this Linux machine, I have to. Where is the add button? Okay, so we'll come to inbound security rules, and then we can see the add button. So you're going to click on add, and you should see this. Now this configuration actually confused me at the time. The why and what is source port, what is source IP, and destination. Now the task now that is on ground is to allow outside that, or probably just my IP address if I want to connect to this VM using SSH. Pardon me. Now this is the goal. I want to allow outside to connect to this particular system. So that means I'm going to create an inbound rule. Inbound, because we want outsider to connect to this particular VM. So just to emphasize, we need an inbound rule. Okay, are you guys following me? All right, so now I'm going to click on add, which takes us here. Now source, as you can see, any means anybody from the internet can access. Then this my IP, it gets my particular IP address. I'm actually going to blur this out, so let us use any for now. So any allows anyone from the internet to connect to this system. Now source port. Source port means those people that are coming to connect to the system, what port are they going to use? Right. So I don't know what port that those systems are going to use, what they're going to use asterisk to allow all ports coming in. Right. But the destination, this source now is for those is the person that wants to connect, not for this particular VM. Now the VM is what we call destination. So destination means that where is those IP address going to land? Now it is going to land. The destination is any. We have not created an application security group, but we'll come back to this. Then custom. We're going to click on SSH for the service. We'll click on SSH to allow anybody to connect to the system through the SSH, and by default SSH is port 22 on the TCP protocol, right? So SSH uses the TCP protocol, and then our action is to allow those devices. Now, if I want to deny, this is the deny button here, I'll just deny, but I want to allow them. And then priority. Now, this priority, how it works is that the higher the number, the lower the number rather. The lower the number equals higher priority. Okay, so lower the number means higher priority. So that means as the number goes lower, the priority becomes more, basically. Now, um, well, I'm going to leave it as 520 because there is no lower number that denies me from accessing SSH. Then the name conversion is very important. So I could say allow any SSH, and then the description, you can put any description here, and I'm going to click on add. So this adds this particular um, network inbound group, security group. So that means that now I can now start to try to connect to this VM. If the VM is powered on, actually, if it's off, it can't be connected. But as you can see here, this number 30 already allows SSH connection. So I don't actually need this. I'm going to delete this. Okay. Now, the outbound rule allows us to filter how the VM communicate with the outside network. Okay, so if we come to outbound security rules, from here we can see that we can add outbound security rule. So source also is from outside, and then destination is going to affect the VM. So that is basically how it works. So that is the NSG. That is using the network security group to filter. And now if you notice, I just wish I could demonstrate it. So let me go back to the VM, right? So just demonstrate the rule. So overview, if I start this, I'll just start this down, and then we'll go to application security group, right? So that when we come back, we can test the NSG. So now application security group allows us to group two or more VMs in a particular group, and allows us to act allows us to use energy to act on those groups. So it affects all the VMs in that particular group. It affects all their inbound and outbound energy for that particular group. So now for the application, for the ESG, we would need at least two VM. So right now I have only one, and I don't know how long it takes, about 5 minutes to actually deploy a VM. Let me just deploy one quick VM so it can be more practical. So I'm not going to use a basic rule for this guy. So basic rule, test 1, 2, 3, no availability, standard be Windows 10 Pro, and this, username is this, password is set. Now you can see that this public inbound. Okay, so if we actually click on allow selected ports, it actually creates a NSG for this VM that we're creating. But if we have our NSG on ground, we can just click on none, so that we can use a group of NSG to control the system network security. Okay, so I'm just going to click on none, right? And I'll review and create. So like I said, I'm using just the basic stuff for this VM. And now, because I want to use ASG on the two machine. Okay, so there's an error. Is there? Okay, I have to agree to this. I think the network inbound is deleted. Okay, now let's create this. Now let's test the inbound connection. I'm going to try to connect to that VM. All right, and then I'm going to delete the rule and try again to connect and see the differences. So this is submitting the deployment information. So let's just wait a moment. All right, so while this is creating, I can come to home, come to virtual machines, come to test VM. So I'll just copy the public IP address and then open my terminal. So this is my target is the Linux operating system. So I will say SSH. Okay, for Linux, I had already downloaded the private key. So I say SSH-I, then the key to the VM, the secure key, then the username, and the IP address. Enter. And this allows me to connect successfully into, oh, it says bad permission. Okay. Let me use it. So chmod is very important that when you download the key to your system, you change the permission to 600 so that it allows you to connect successfully to the VM. But basically, it actually allows us to actually connect to the system. Beautiful, beautiful stuff. Now I'm going to exit and now come back to the network security of the same VM. I would go to all right, so this is the inbound connection, right? I can click on this and this is delete. They don't delete, it's just to manage. Okay, sorry, let me just use deny actually. I'll deny this and I'll save it. Okay, so deny this inbound connection. So sometimes the NSG might require us to restart the VM to apply the rule, but let's just check if it's going to work. Oh, it still works. All right, so let's restart the VM. Sorry. I'm going to restart this. Now we'll go back to virtual machine. We're going to refresh this. I hope it is not confusing, guys. Please, hope it's not confusing. Please, hope it's not confusing. Now, to enforce application security group, that is ASG, we want to group these two machines together. Is it application security group? So from up here, I'm going to search for ASG. Yeah, the recording is going to be provided. Trust me, it will be provided. Then I'm going to click on the application security group. So right now we don't have any application security group. I'm going to click on create. Okay, so I'll select my resource group, still the same resource group that I use. I'll say ASG VM as the name, EastUS. Then I'll review and create. Then I'll create this. Okay, so I'm going to, okay, the deployment is in progress. Now, while it is in progress, let me try to connect back to the VM. You can see that now it's taking time. And oh, it's still connected. Then that means we have to check the rule of the machine. And that is the work of the network watcher. That means I still have to go back to check which rule actually still allows the SSH, because there has to be another rule that actually allows SSH. to connect. So we're coming to the network watcher, monitor if a particular VM or IP address has access to the port of the VMs in the network. Okay. So now we've created our ASG. Let's go to the resource. We come to the settings. Where the settings? A moment. Okay, so we can see that this is the overview page, and we can see that it allows us to move to another resource or under subscription. Then we're going to go back to our VM, our virtual machine. Then I'm going to click on this particular VM. And then here I can see application security group under the networking tab. So I can add to application security group. And just like how I've created this, I'm going to add this VM to the ASG. So basically, like I said, this ASU groups to more VM for a simplified network security. So this is in the ASG, then I'll go on to the next VM, then click on application security group. Then I'm going to add this as well to the application security group. So this is basically how you add a VM to an application security group. Are we getting it so far? Are we getting it so far before we continue? Now that is the NSG and that is the ASG. So basically now, if we now come back to our network settings and we want to enforce a particular rule, we can enforce it based on ASG. So if we want to create an inbound rule, so I'll say that, okay, any device can connect to the central is any, or I can say application security group now, because we now have a new application security group. So that basically any VM in this ASG, they will receive this particular rule because now we're acting on this group of VMs, this group of application service. I'm going to pick RDP because I need RDP for the Windows. Then action is to allow priority is 100, then name, use a naming convention by the company so that others can understand. And then we're going to click on add. So it's down to group VM based on their capabilities now. So basically grouping Linux and Windows together might not be the best. It would be better if I group Windows VM because they are similar in nature, while Linux is different. So that is basically the NSG and then the ASG. And as usual, it is very important to always power the machine off so that it does not incur cost on your subscription. Okay, let me keep this one on for the next lab. Now, in virtual network, we have something called Okay, let me click on. Though I've not added those other VMs to this VNet, but we have something called under the monitoring. Sorry, is it monitor settings? Network. Okay, sorry, it's not important. So let's search for network watcher. So we have a network watcher, which is a management, which allows us to manage our subscription, sorry, our resource, sorry, is it resource group now or region? Yeah, region. It also monitor our region network, virtual networks, and test connectivity so that we can be able to diagnose uh, our connection. So on the left hand side, we can see monitoring that allows us to view the topology of our old subscription. We see the connection monitor, we see the traffic analysis. And on the network diagnosis tool, we can see the IP flow verified, the energy diagnostics. The next up, we have the security rules, packet capture, connection troubleshoot, and so on. Now, if we should click on the topology shows us a broad overview of our virtual network, right? So we can see that we have two regions. We have the East US region, and then we have the West Europe region. So my focus for today is going to be the East US. So I click on it, and sorry, let me just expand. Oh, mistake. I want to expand the topology actually. So expand. Now, in my ECS region, I can see that I have these virtual networks. Then I have the web VNet, I have the test VM VNet, then I have the digital workspace VNet as well. So now I want to expand this particular VNet. So I'm going to click on it and I can see the attached virtual networks to this. So this tells that these are grouped virtual networks, that these two are grouped together. So if I want to ungroup them, I will click on this, but I'm not doing that. Oh, why do I keep pressing this X button? Sorry. So expand this again. Then this test VM is our virtual machine VNet, and we should be able to see some details about this particular virtual network. So we're going to expand this as well. So this just gives us a topology view, and then I just zoom in a little bit. So we can see the connected devices to this particular virtual network. We can see that there is a network security group. There's an IP address attached. There's a network. There are 3 network interfaces attached, and these are just the graphical view of this. Then we can see that there's connectivity for VM2. The test 123 VM is actually shut down, and that's why the health status is unavailable. And so for others, it tells us that the health status, that this one, the health status is available. Now, if you click on connection monitor, this allows us to monitor our connection, but we've not actually set this up. Before we come here, let's check the IP flow verify. Now, network watcher IP flow verify checks if a packet is allowed or denied from a virtual machine based on 5 token information, which is the security group decision and the name of the rule that denied the packet will be returned. So for now, it allows us to check the flow of IP in our network. Now I'm going to use this virtual machine as our target. Then the network interface, there's meant to be a network interface. Sorry. All right. Test VM 2152. And then protocol is the TCP, inbound is this. So local port, we're going to use 5,000. Then remote IP address, I don't know, I'm going to use 8.8.8.8, remote port 80. So let's just verify this flow and the nodes that it will bring for us. Now we want to see if this remote IP, this Google DNS can access this VM on this particular port. So it says that it is allowed, and the reason why it is allowed is because on the NSG there's a allow any inbound on that particular port number. Okay, so now if I change this to 22 for SSH, and then I click on verify IP flow. Just wait a moment, and then it tests the connection. So this gives us guys, can you hear me?
Oh, we can hear you guys.
Yes.
Okay, thank you. Sorry, a little network. And the network issue cannot stop me. All right. Let me share my screen once again. I'm sharing it once again. Can you see my screen now?
Yeah, visible.
All right, beautiful, beautiful, beautiful. So it shows that there is, even though I denied, you guys saw that I denied the energy, but we can see that there is still this rule that says allow any custom, any inbound that still allows SSH. So I guess that's where the issue came from, that even after I denied the, all right, so this is it. This 200 priority alert, so this 200 priority still allows us to connect through any to this particular test VM2. So I'm going to delete this 1 and 2. Let me come down to inbound security rule. I'll select the 2 and I'll delete those 2 rules. Just to demonstrate. And okay, deleted. Now come back to IP flow verify. And I would try again. Hopefully network does not disconnect. And we'll see if anyone can have access to that particular port. So just basically so that you guys can understand how the network security group allows and denies traffic. Okay, so we can see that it's now an access denied. So if I should come back in and try to connect to the VM, we should not get a response, or we should not be able to connect to the VM. the IP flow verifier just tells us that it's not possible to connect because there's a deny all inbound rule. That, and since there's no higher priority alert, which comes with a lower number, I said it that the lower the number, the higher the priority. Okay, and this deny all inbound is actually like on a high number, and there's no lower number that supersedes it to allow SSH. So this is going to take effect on this particular rule. So this is taking time. That means it is unable to connect to the VM. So that is the IP flow verify for diagnostics feature. And then one more is the next up that I'll demonstrate as we close up the session. So this next up just allows us to view the next IP address. Just on our subscription, I think I'm on this subscription, on this resource group, and I would select my virtual machine, then network interface this source IP of the VM. This is the private IP of the VM, then destination. If I want to connect to 8.8.8.8, which is Google DNS, it just tells us what is the next IP address. So, I mean, we know Azure has some cool features, but this just, it's just part of those other one that is just there. It just tells us the next IP address or the next up to the particular, which is the internet, to this IP address. So the next up that it goes through the internet to get this IP address. So nothing so spectacular about it. So this is where we'll be rounding up for the practical lab. We've talked about NSG, we talked about ESG. So not to crowd your knowledge, it's important to take it bit by bit and to understand how it works so that you can apply it in a real world scenario. So we'll just bring this to a close at this level. Thank you so much for having me here. Over to you, Mr. Emmanuel. Hello, sir. Can you hear us? Mr. Emmanuel, can you hear me? Okay. Does anyone have a question? Please, you can drop your question down in the comment section, and you can also raise your hand up and speak. Yeah, Mr. Solomon, please, you can go ahead.
Okay, thank you so much, sir, for this wonderful class.
Thank you so much.
I've actually learned a lot.
Thank you so much.
My question is about my developer tenants. So whenever I into the Azure portal, that I call to create a virtual machine. By the time I click on it, I don't know. I don't know if it's because I don't. Although the account I have is P2. That is the license I have P2. So whenever I logged in, if I click on start, they're only telling me to start a free trial. So and apart from that, in order to create virtual machine, it's not giving me access. So I don't know if there's any permission I needed because I actually created this account 2 years ago, the developer account. I don't know if the fault was from when I was creating it or it's because it's a test tenant. That is why
so your question is what?
So my question now is, whenever I want to create a virtual machine, it's not giving me access on my own developer tenant accounts.
Stephen, let me take that.
Okay,
Let me
sir.
take that. Solomon, so basically, the developer tenant give you access to Microsoft 365 subscriptions. Before you can create resource on Azure at all, you need to have an Azure subscriptions. So an Azure subscriptions could be in different category. It could be the PRC Go, you can have the trial subscriptions, you can have it as a virtual studio subscriptions. So you need to actually have an Azure subscription on Azure. So I don't know if Steve, can you share your screen? Show them the subscription that are on the tenant that you're using to practice. There are subscription on the tenant that are actually peculiar to Azure. So developer tenant is only for M365 side. It's all for Azure, basically.
Okay, okay.
Yeah,
The
go to
subscription. This one.
yeah, subscription, yeah. So you need to have at least one subscription to be able to provision resources on Azure because every resource groups need a subscriptions, basically. Yeah.
Thank you so much.
All right, noted, sir. Thank you, sir.
All right, I'm about to use service, Emmanuel.
Okay. Sorry, but I want to probably get a subscription based on probably pay as you go. How could I go about it? But I'm seeing the prices here, the current prices over here.
Okay, if you go to subscription, where's Steve is, just click on add.
Okay.
You click on
okay,
add.
okay.
You see different categories of subscription that are available there. So this first check your eligibility, maybe just there's if you're a student, you have like maybe you're doing a master's, you have your school with your school email can be eligible for subscription for students, right? That gives you $100 credit, I think. Yeah. So to check your eligibility based on
Okay.
eventually to pop up. So there's a free trial. So if you're eligible for free trial, it will just click on try for free. If you want to do pay as you go, just select offer. Then if you're a student, you select offer too. So that is you have to have like school email address for that particular one.
Okay, okay. Thank you, sir. Need to practice.
Okay, yeah, Steve, wonderful session. Thank you for this session. We have a question for you. So Theodore is saying that I don't really get the ASG and NSG. Do you want to go over that again?
Okay, sure. I can go over it once again. The ASG. Okay, let me just share my entire screen so that I can show. Can you see my screen?
Yes.
So the NSG, right? NSG, its own primary purpose is to secure your virtual machine, which it secures the inbound and outbound connection to the virtual machine. So this is the primary purpose. It's like manages who can access the VM. So basically, the network security group is on the network level and it blocks or allows connection to the port of the virtual machine. Port is actually like a virtual port that allows VMs to communicate. So while the ASG, which is the application security group, allows you to group two or more virtual machines, right, in a logical manner. So basically, the ASG purpose is just to group, from the name application security group, it groups application, it groups VM. And so after you've run with the ASG, which is to group maybe VM1 and VM2 and VM3 inside one single ASG called maybe group VM. So basically, this group VM now contains all these three ASG. If you get me, so this group VM contains VM1, contains VM2, and contains VM3. So now the way they now combine is that instead of you single-handedly coming to NSG to block inbound and outbound for this particular VM first, and then now go to the NSG and block inbound and outbound for this particular this VM2, and then now do the same process all over again for VM3. As long as these three, for example, they are these three VM, if they are used for web application, like for websites, if it's for website, that means that they use a similar type of inbound and outbound communication or connection. So you can group these three inside this particular group VM1. And then when you now come back to the NSG, so you now say NSG should apply rules, that is the inbound and outbound rules, sorry, rules for the group VM1. So now whatever rule that I allow for this group VM1 affects all the three because they are in the same application security group. So Theodora, I've answered your question. Okay, thank you so much, Mr. Emmanuel. It says if an using
Yes,
AVM.
I think it's clear now.
All right, thank you so much, Theodora.
So I've dropped a link for you today. You can check that link to read further on both NSG and ESGs to get other insights around that. All right, thank you so much, Stephen, for this wonderful session. It has been insightful. It has been amazing. Thank you so much, and thank you for everyone that joined us today. We're super excited, right? We are kicking off securing virtual network. So in the next 2 weeks, you're gonna have another session. Still, it's gonna be continuation on virtual networks, where we'll discuss our private security for private access to Azure resources, then followed by security to public access to. So those two sessions will be happening by next month in April. So we look forward to having you around for those sessions as well. So thank you so much, everyone, for joining. So have a lovely weekend. Bye for now.
Thank you everyone for joining.
Thank you, sir.
Thank you, Theodora.